Okay, guys, today we're going to be talking about why psychology. This is a little bit of an intro into our scientific method, but talking more about, we've talked about the history, but we're looking at now, why do people think that psychology is necessary? Isn't this stuff just common sense or things people know? So we're going to talk about some big vocabulary terms in this next lecture. And let's start out with why we need science in psychology. So we talked about last time that psychologists are considered scientists, and they use the scientific method to construct theories that organize observations about behavior and then putting them into testable hypotheses. Okay, so we're going to talk about how psychologists observe things in nature and then how they test those things out to come up with conclusions. Okay, so why we need that. So we're going to talk about a few things. The first one is called the hindsight bias. Okay. The hindsight bias, if you've ever heard that expression that hindsight is 20/20, that means hind meaning is like things that are behind you, meaning that when you look back on something, you can see it perfectly versus when you were there the first time, it might not have been so clear to you. So the hindsight bias means that we tend to believe after learning something that we knew it all along. Okay, so the classic example of this is watching Jeopardy! So you'll watch Jeopardy and there'll be a question that's asked and the people will answer it first. And you're like, oh, I knew that. Even though you might not have known it. So it's called the I knew it all along. Or I hear this all the time as a teacher when you're going through multiple choice. They're like, oh, I knew that, I just didn't choose that. That's called the hindsight bias, thinking that you knew it looking back. I knew it all along. I just made a mistake at the time. Another thing is called overconfidence. Probably know what this means. It just means that you are overconfident in your knowledge. So the overconfidence is a vocab term, means that we tend to actually think we know more than we do. All right, it's just that simple. Example, so if you look at your screen here, this is a list of anagrams. So this is something that was actually confirmed in a laboratory setting. So people were given this list of anagrams here that you see right here, these three words, and they were asked with the answers, how long that would have taken them to solve. And on average, people said, oh, I could have solved that in 10 seconds, all right? Now, when they actually tested these anagrams out in a laboratory setting with people of all intelligences, it took them about 3 minutes to solve. So when you see the answer, you were pretty sure that you could have gotten that really quickly. Versus when you're actually put in the situation, people took about 3 minutes, okay? So overconfidence, the tendency to think that we know more than we actually do. Another need for it, pseudoscience. Okay, so this is popular beliefs that seem to be related to science. So psychics or people that read stars or read palms, it's considered a science because there's like a procedure to it, but that's not an actual science. So these things have been disproved, and we'll talk about some reasons why they tend to look like they work, but not. So one of them is your horoscope. So we'll talk about your horoscope here in just a second. And that is, so with your confirmation bias. So your horoscope is a perfect example of a confirmation bias and why they work. So the actual definition of confirmation bias, so you're confirming things that you are looking for evidence to confirm things that you knew. All right, so when you look for evidence to confirm things that you think are right, but you ignore all the evidence against it, that's called a confirmation bias. So your going back to your horoscope. So your horoscope says for the day that you will have something really good happen and then something really bad. Horoscopes tend to be broad, and then people tend to kind of cling on to the thing that did happen and forget the thing that didn't. So oh, my horoscope said something bad was going to happen today. And then they forget that that it said something good as well. Another confirmation bias, this is true of people, is that when you have these preconceived notions of what you're looking for, you tend to find it. So if I have the bias that I think teenagers are disrespectful and I want to go out and prove it. So I go sit out in the quad during lunch and I am taking notes. If I have the idea in my mind that teenagers are disrespectful, I tend to notice that more. All right, so this is actually really interesting, something to think about. When you have preconceived notions of someone or something, you tend to look for those things to confirm it, and you ignore all the things against it. That's why they say that first impressions are so important, because if you make a bad first impression and you already have that idea of someone in your head, you might always be trying to confirm that bias, versus the other way around. Maybe you really like someone and you are only looking at the things that are positive about them, but you are forgetting all the the things that are bad about them. We tend to notice this with our friends, like, why do you like that person? They're this and that and that. And but if you're that person that likes someone, you only notice the good things. Okay, so confirmation bias. So what? All this sad news about things that we know: overconfidence, hindsight bias, confirmation bias. So what can we do to overcome those pitfalls? This is where science really takes a huge role in psychology. We implement the scientific method, and we try to get rid of things that we're skeptical about. We try to have humility, meaning that we thought something and now we are going back on it. And critical thinking. So we're going to talk about critical thinking here in just a second, but your teachers probably tell this all the time, like, you need to think critically about what you hear, think critically about what you read. We're going to put a definition here in a second. So the biases, confirmation, hindsight, and errors of people's just everyday judgment lead us in psychology to look for these three things. Okay, so critical thinking. When teachers tell you to think critically, or when we say it in psychology, what we're asking you to do is you're not blindly accepting something because it's on paper. You're not blindly accepting something because someone important said it. All right, so when you critically think about something you hear or see or read, you are examining assumptions. Okay, so that's one part of it. You are looking at hidden values. So where is this person? Who is this person? Where are they from? What are some of their values that they have? You're evaluating evidence. We're always looking for evidence in science. That's why psychology is considered a science, because you need evidence to back up your whatever you are claiming. And then you're assessing conclusions. So if this person made a conclusion, you're going back and you're looking at the assumptions that they made, where this person is coming from. You're looking at the evidence and seeing if that evidence backs up the conclusion. Okay, so when we tell you to think critically about something, that's what we're looking for. Who did it come from? What did they conclude? Why did they conclude that? Where is the evidence for it? So critical thinking. So here's an example. So if you're giving the statistic that 1 in every 3 teenagers could be less intelligent than their older counterparts at their age, right? So 1 in 3 of high school students is less intelligent than someone their age. Would you just accept that? We tend to hear statistics, and because they're worded in such an intelligent way, we accept it. So there's kind of that joke that 98% of statistics are made up on the spot, which is a statistic. So it's supposed to be funny. Hopefully you just laughed. But that's where we're going to, in psychology and hopefully in life, we're going to really try and implement this skill, is that you're always thinking skeptical about what you read, what you hear, what you think, what I say. Where'd you get this information? How do we know? That you're not just blindly accepting or just believing, is another way to say that, everything that you hear. All right, so our goals of psychology, what we try to do with psychology to make it a science. So first of all, psychology, going back to its definition, we're looking at, again, behavior and mental processes, things that we can see, behave, or watch behaviors, and then the things that go on in the brain. So we're looking to describe those, okay? So what it looks like. We're looking to explain it, so look for an explanation behind what we are seeing. We want to be able to make predictions, and we also want to be able to control some things that happen with our behavior and our processes. So those are the goals of psychology with science, okay? How we do that? Research. The scientific method we will talk about in class, because you will be coming up with an experiment, but just a brief explanation from your science classes that you've taken. So we're looking to develop hypotheses. All right. Once we have that, we're looking to collect data, right? We have to have data or evidence to back up our claims. So experimental and descriptive. So data can be numbers, and it can also be things descriptive, like what you observed. After that, we need to analyze our data. So we have all these numbers, we have all these descriptions. We're going to have a unit on statistics. Don't freak out. But looking at how things are statistically significant. And then meta-analysis. So we're looking at, analyzing numbers and then analyzing thoughts, okay? And what we ultimately want to do with that is, there's no point in going through the scientific method. We talk about this in my bio class. If you don't publicize it, and it has to be replicated, or it has to be able to be replicated. So if you have this amazing experiment with these great results, people have to be able to replicate your experiment in order for it to be considered a valid experiment. Okay, you can't say I cured cancer and then not be able to explain people how you did that. Okay, so a hypothesis versus a theory. Again, this is definitely going back to your science classes. But in psychology, what I really want you guys to focus on for hypothesis is any sentence that, and you'll probably see this on your AP test, any sentence that has an if-then situation. If I wear polka dots, I will be happier. Okay, that's my hypothesis. If I do something, or if this happens, then this will happen because of it. Okay, versus a theory. So a theory is a testable prediction, but it's implied by hypothesis, but our theories tend to have a ton of research behind them. Okay, so in biology we talk about the theory of evolution. So that's not just a hypothesis that someone came up with and they're testing it. A theory is being applied in a new situation. Okay, the theory of evolution, that species change over time. It's based on a ton of evidence. It is basically considered a truth. So theories are as close to truth that we get in science, because it's describing things that we cannot see, things that happened too far in the past. So the theory of evolution is considered that because we have all this evidence to show that it happened, but we didn't actually watch it happen. Operational definition. Okay, if we're going to talk about this in class, but if you have questions on this, I want you to write them down. This is a big one. There's always questions on operational definitions in your test. Okay, so I'm going to scroll down so you can pause it and write this down. Okay, so an operational definition is a statement of procedures. I'm just going to read this to you first. So statement of procedures used to define your research variables. Okay, one more time. Procedures that are used to define your research variables. What that means is it's basically telling you how are you going to measure a variable. Okay, so going back to my example, if I say that polka dotted socks, my hypothesis, if I wear polka dotted socks, that will make me happy. How am I going to define the variable of happiness? All right, so how am I going to define or measure being happy? Okay, so we have to say how we're going to measure it and how we're going to manage that. All right, so am I going to measure happiness by how many times I smile that day? How am I going to, or maybe I'll measure happiness by how many times, how many minutes I laughed that day. Right, so I'm coming up with a definition of how I'm going to measure something. The big key on this one is that it has to be able to be replicated. Okay, so if I tell someone you're going to measure how happy you are during the day, then I have to have something that can be measured and someone that, someone else could measure it. Okay, so how many times I smile, how often I laugh. All right, so again, we're going to talk about you need to be able to replicate an experiment. Okay, so repeating is the essence of a research study. It really means nothing to the scientific community if they can't replicate the experiment and then replicate those participants and circumstances. Okay, so if I'm taking a random collection of people, I need to be able to do that in another situation. The goal, the ultimate goal is to be able to repeat that experiment with different participants in situations and get the same results. That's when something becomes replicable. That's when something becomes valid, is when I can take the same experiment with different people and get the same results. Okay, you can't have this magical thing happen with a group of people and claim that, like I said, you cured cancer with these 7 people, but no one else is able to replicate that anywhere. So that's where we get replication is like a huge need in the scientific process. All right, so here's a quick example. We're going to talk about these different types of variables and hypotheses. Miss Myers just getting a text message. All right, so a hypothesis. Let's let this pop up. So I want to study sleep. Okay, so I have this group of people and they have insomnia. They're not sleeping. So my hypothesis is that if people take X amount of sleeping pills, then they will sleep better. Okay, so helps the healthy person with insomnia to sleep better. So if I say they take 2 sleeping pills, they will sleep better. That's my hypothesis. If they take this, then this will happen. An independent variable, you probably want to pause it here and write the stuff down and then go back. So independent variable is the thing that is changing. Okay, so my thing that is changing in this situation is the amount of sleeping pills. So that's why it says X up here. If I say 2 sleeping pills or 1 sleeping pill or 0 sleeping pills. Okay, we will talk about a placebo group probably in class, but a placebo group is kind of like your thing where you would have a group of people that don't get sleeping pills. Okay, so a group of people that get sleeping pills, people that don't. And then we have, so this is called my experimental group, is the people actually getting the sleeping pills. The control group are the people that don't. Okay, so the dependent variable is the thing we are measuring, okay, because of what's changing with the independent. So my dependent variable in this situation is the number of people who slept, who had a restful night's sleep. I can measure that, okay, so I can say one person did, 2 people did. If my hypothesis proves to be incorrect, people taking the sleeping pills over a period of days would have more insomnia than before. All right, so we're going to talk about creating a hypothesis and a null hypothesis later. All right, and this is just a really quick picture of the research process. So what I want you to get from this, you don't have to copy it down, is just that it's cyclical, that it doesn't start and end in one specific place. A lot of times you see the scientific method kind of going like this, and I like this picture better, where we're starting with an observation, coming up with hypothesis, testing it, going back and making more observations, theories, hypothesis, and it's a continual process. It's not some place where it starts and ends. That's a great part about science, is that it continues on. Now, I want you to take this scientific type of process and apply it to things that we're doing in psychology and see where the connections exist, and then we'll talk about where things can't be replicated and the kind of the pitfalls we have in the scientific method.